Hi, people! Okay, today we are going to solve some more equations. This time it's going to be a major step up here. You're used to solving an equation with one variable, like this one. You're like, oh my gosh, that one's so simple. You just use the subtraction property of equality, and you end up with x equals 5, right? We just need a value for x. But now I'm going to ask you to stay positive, like me, right? And you are going to be so happy about this because you want some higher level problems here. We're going to solve what's called simultaneous equations. So now I'm not just going to have one variable, I'm going to have two variables that you need to figure out. So if I have two variables, that means I have to give you two equations. So I'm going to say, let's let 2x plus y equal 9, and I want 3x minus y to equal 16. I want, no matter what I plug in for x and for y, I want this to be true. Whoops, and I just erased it. Okay, I'll rewrite it. 2x plus y equals 9. I want this to be true, and I want this to be true. So if I plug in and let x equal 1 and y equal 5, if I plug it into this top equation, to this one, will it give me 9? And will it also, when I plug it in here, give me 16? Well, no, because that was a total guess. So I need to find those numbers for x and for y that if I plug it in to not just the first equation, but to the second equation, it's going to be true. So how the heck do we do that? Well, get excited, first off, because it's two equations and it's two variables. So we're going to use what's called substitution. That's what's going to be your life in this, okay? Substitution. So if we take 2x plus y equals 9, and the second equation, 3x minus y equals 16, we need to solve for one of the variables, okay? And then we're going to substitute it in to the other equation. So to see what I mean, we actually have to do it. So I'm going to look at which variable is going to be the best one to solve for. And the things to look for are to look for a variable with a positive coefficient. That means a number in front of it that is positive. And the most preferable would be for it to be a positive 1. A negative 1 would be the second best. And then after that, you're just looking for good numbers. So when I look here, I see a 2 for the coefficient in front of the x, so that's nice that it's positive. I see a 3 in front of that one. I see a negative 1 in front of that y, so we're getting good. And then I see a positive 1 in front of that y. So right now, this y is looking like the best one out of all the equations, which there are only two, the best one to solve for. So I'm going to take this equation, and I'm going to rewrite it to look a little different. I'm just going to solve for y. So to solve for y, I need to get rid of this 2x that's being added on. So which property am I going to use? I'm going to use the subtraction property of equality. So I'm going to subtract both sides by 2x by using that subtraction property of equality, and I will get y to equal, well, I can't put these together because they're not like terms, so I'm just rearranging the equation, that's all I'm doing. And I'll get y to equal negative 2x plus 9. Negative 2x plus 9. Or if you don't like it written like that, it could be written as 9 minus 2x. Either way. So we're going to take that first equation and we're going to rewrite it to just look a little different. So I'm going to rewrite it as y equals negative 2x plus 9. So all we did was solve for y. So now I'm not using that equation anymore. I'm using it like this. Now I'm going to take that equation and I'm going to sub it in to that second equation. I need to put them together somehow. And that's how I'm going to do it, through substitution. So I'm going to take what y equals. Y equals this quantity. And I'm going to sub it in right there for y. So I'm going to take out that y and say, okay, it's not y anymore because y is actually equal to this quantity. And I'm going to sub in that y is really the same thing as negative 2x plus 9. So what I've done is I've taken both equations and I've now incorporated them into one equation with one variable. So now I can determine the value of x. And this is one of our more complicated multi-step equations to solve for. So the first step that I need to take here is working with this left-hand side. I need to simplify this side. And to simplify it, I'm going to have to use which property? The distributive property, first off. I have this negative, which needs to be distributed to both of the terms inside. If you want to think of it as, I need to take the opposite of everything inside the parentheses. So instead of 3x minus the quantity of negative 2x plus 9, I could read it as, I need to do 3x, I need to take the opposite of everything in here. So I'm going to have 3x, and then if I take the opposite of negative 2x, I will have positive 2x. And if I take the opposite of 9, that would be negative 9. And that is supposed to equal 16. So really, I was distributing that negative through to take the opposite of everything by using the distributive property. Now the next property, I'm going to still have to simplify. I'm going to have to combine like terms. So I'm at 5x plus, well, that's not a positive 9, it's a negative 9, equals 16. So if you want, you could just write that as 5x minus 9. And now, by the addition property of equality, we're getting close. 5x is going to equal 25 because I added 9 to both sides. And then by the division property of equality, x will be 5. Now you're like, yes, got what x was. I am done. Well, the thing is, remember, this was a simultaneous equation where we had two variables that we need to solve for. So now we've determined the value of x. Now we need to figure out the value of y. Well, what's cool is that we already solved for y. So what I could do is take this equation in which I already solved for y and use it. So we said y equals negative 2x plus 9. And I'm going to sub in what I know x is. I know x is 5. So I'm going to go y equals negative 2 times 5 plus 9. I'm subbing what I know x is already, so I can figure out my value for y. So y equals negative 10 plus 9, which would be negative 1. So now I have an x value and I have a y value. I have both my variables. Now, was there a z variable? No, not yet. I haven't done that to you. So there's only two equations, two variables, and we figured out what both of them are. What do you think the last step is? Well, your favorite, to check it. So this was supposed to be true, back to the original problem, and so was this. And it is actually a neat thing to check it, because then you actually see, oh my gosh, it actually worked. That is so cool. So in this first equation, I have 2 times my x value of 5 plus my y value of negative 1. And we're seeing, is that going to be 9? Well, this would be 10 plus negative 1, which is 9. Yes, it worked. So it worked for that equation. Does it work for the second one? So it has to work for both. So let's see, in the second one, 3 times 5 minus, what did we get for y? Negative 1 equals 16. So we're at 15 minus negative 1. Is that 16? Well, on the number line, we'd be going 15 minus, you think you're going left, but then it's negative, so you keep going, so you're really adding, and you do, you get 16. So our values that we figured out for x and y worked. And how do we do it? By substitution, it's called, in what's known as a simultaneous equation, where you have more than one variable. And you were so excited about that. So I'll see you tomorrow in class to practice it.